All right, so we talked about transforming a little bit in class today. So if you add or subtract to a distribution, or if you multiply to a distribution, what does that do? So first of all, transforming converts the original observations from the original units of measurement to another scale. What does that affect? Well, that can affect the shape, the center, or the spread. And we're going to be doing a lot of basic transformations, so in general, the shape won't be affected too much when we do. In fact, it won't change at all. Some of the stuff we'll do later in the year when we take like the log of the distribution, or you can square root the values, that would affect the shape. But the stuff we do, it won't affect the shape. So what about adding or subtracting a constant? We're going to call that constant C for our purposes. So if you add or subtract the constant, what does that do to like the shape, the center, or the spread? Well, if you have to do it to every single value, so every single height, let's say, for the classroom, that's what the first example is, that changes measures of location and center. What do we mean by that? You guys know what measures of center are, like mean or median. Measures of location, remember, that could be percentiles, quartiles, even z-scores. Okay, so we got that taken care of. So what about spread and what about shape? Well, if you look at, let's say the first example here, I'll circle it, this guy. If you add, let's say, 5 to all those, it's definitely going to shift everything that way, 5, but it's not going to change how wide it is. So the spread will not change if you add or subtract a value to it. It'll shift all the values up or down, but it won't change. Further, it also doesn't change the shape, so the shape would remain unchanged. So if you add or subtract a constant, that will change the values of location and center by plus or minus whatever the constant was, plus or minus C. But for spread and for shape, it does not change those values. So it does not change shape or spread. And when we talk about spread, we mean like range, IQR, or standard deviation. Those are all measures of spread. But it does change measures of center or measures of location by plus or minus C. So that's the only thing it affects by adding or subtracting a constant. So what about multiplying by a constant? So we'll use C again. So if we're multiplying or dividing by a constant, it's pretty much what you would expect. You multiply or divide all the measures of center, so they just get multiplied by that constant. We're going to say C again, so you multiply or divide measures of center or measures of location. Multiply by C. What about for shape or spread? So for spread last time, range, IQR, standard deviation, those aren't affected when you add or subtract a constant to everything. So if you add or subtract a number, those aren't affected. But when you multiply by a number, those are actually affected. And it's still pretty simple. So if you multiply or divide, that multiplies or divides the measures of spread by the absolute value of C. So I just want to be clear. Even if you multiplied everything by negative 10, then your standard deviation, you just multiply that by the absolute value of negative 10, which is just 10, right? So you just can't multiply it by a negative number. In fact, we said in Chapter 1 that you could never have a negative standard deviation. So that's why this is there. So even if you multiply everything in the distribution by a negative number, our standard deviation still has to exist. So that's going to be by the absolute value of C. We turn things positive for standard deviation. We said already that shape is really unchanged. Whether you add or subtract the number, or whether you multiply or divide by a number, our shape remains unchanged. So shape does not change. All right, let's look at the first example. It says the figure to the right shows the height distribution for one of Mr. Bishop's stats classes along with summary statistics from computer output. So down below there, those are the summary statistics. Number there are, the mean, the standard deviation, the min, Q1, median, Q3, and max. Those are the values. Suppose you convert the class's heights from inches to centimeters. Even give you the conversion right here. 1 inch equals 2.54 centimeters. Describe the effect this will have on the shape, center, and spread of the distribution. So what does that entail, converting it from inches to centimeters? Well, you're going to get bigger values, right? So what happens when you multiply each observation or each height by 2.54? Okay. Well, right away I want you to think about which values get affected between shape, center, and spread. So for shape, center, and spread, which ones get affected? Okay, right away you should think we're not going to be affected in terms of the shape. But the center, if every single value in there gets multiplied by 2.54, that should multiply our center by 2.54. So converting, I'm going to use context, converting class heights from inches to centimeters, has no effect on shape. So it has no effect on the shape, right? But multiplying, or it multiplies the center, or the mean, or the median, whichever one, by 2.54. So if we were to do this, currently the mean height is 67. The new mean would be 67 times 2.54. Whatever that is, I'm not going to get that right now, but that's what the new mean would be. Further, what do we do for spread? So spread, we're talking standard deviation, right? So we take the standard deviation, and we're not multiplying by a negative, so it's pretty easy, and just multiply that by 2.54. So, and it multiplies the spread, in our case, any of range, IQR, standard deviation. Usually we'll use standard deviation by absolute value of 2.54, which is just 2.54. So we didn't even actually have to calculate any values here. It just said, what effects would it have? Describe those effects. Describe the effects it would have on the shape, center, and spread. It didn't say calculate any new values. So that's what we did. We just described it in context here. So looking ahead for Part B. So if Mr. Bishop had the students stand on a 6-inch high platform and then had the students measure the distance from the ground, how would the shape, center, and spread of this distribution compare the original height distribution? So that's from the ground to their head, actually, right? Everyone stands on a 6-inch high platform, so now you're 6 inches taller than you were before. What's the new distribution look like? Well, we should be able to take those dots. If I can just go back one, we could just take these dots and shift them up 6 units, right? Because everyone stood on a 6-inch high platform, so up 6 units. What would that do to the new mean, the new standard deviation, and so forth? Okay, well, since our mean was 67, I guess our new mean would be 67 plus 6, would be 73. Okay, so in general, we're just looking what happens to the distributions if you add 6 inches to each height. So, two things will not change. You should have a pretty good idea of what two things will not change, and the one thing that will change. You add 6 inches to what? Well, we just talked about it, right? So if you're going to add 6 inches to the mean, the measures of center, the two things that won't change are the shape and the spread. So adding 6 inches to everything in the distribution, shifting it up 6, won't affect the shape or the spread, but it will add 6 inches to the center. So whether it's the mean or the median, it adds 6 inches to those pieces. Okay, last part here, Part C. It says, now suppose that you standardized the distribution of the class's heights. What would happen, or what would the shape, center, and spread of this distribution be? So that's what it should say. What would be the shape, center, and spread of this distribution? So what does it mean to standardize the distribution? Think about that. That actually goes back to z-scores, right? So if you standardize, that means you convert to z-scores, which requires some basic math. But that's what we're talking about here, is adding or subtracting values, multiplying or dividing values. So to convert to z-scores, we know the formula, right? Z equals x minus x bar divided by the standard deviation. So for everyone in our distribution, they're their own individual x. So what we're asking is, to each individual, can you subtract the mean and divide by standard deviation? And what does the new distribution look like? So think about that for a second. And I guess the order really matters here too, right? So for each height, you would take each height, subtract the mean, then divide by the standard deviation. So then divide by the SD for short, the standard deviation. Okay. So that's really going to influence our measure of center, right? So we can let's find our new mean. So our mean was 67 before. So what's the standardized mean look like? The standardized mean. We're going to do this right here, right? We're going to subtract the mean and divide by the standard deviation to each person. So how does that look? So if the mean is 67, right? If the mean is 67, so our new mean, so we minus 67, which I know that's going to be 0, right? And divide by standard deviation, which is 4.29. You know what? I want to get the handout here. Can I get? Yeah, I like the green hand. Nice. 4.29. Okay, so our new mean is 0. Take a second to think about that. So if we standardize it, we convert it to z-scores. From each individual, we subtract the mean, and we divide by the standard deviation. So now our new mean is 0. So that's the math. Take the mean, take the mean, subtract the mean, which is why we got 0, divide by standard deviation. That's 0. Okay? So our new mean is 0. What about our new standard deviation? So our standardized SD, or standardized standard deviation. Okay, well, first thing you need to know is that subtracting 67, right? Subtracting the mean, that doesn't do anything to standard deviation. We already talked about that. Adding or subtracting a constant doesn't change measures of spread. So the only thing that's going to affect the standard deviation here is this dividing by 4.29 piece. So when we divide by the standard deviation. So let's note that. So subtracting 67, or subtracting a value, has no effect, but dividing by the absolute value of 4.29 does. And I'm just, to be clear, it's absolute value of 4.29. We won't really need it here because it's already positive, but that's technically the definition. So what's the new standardized standard deviation look like? 4.29 times 1 over absolute value of 4.29, right? Because dividing by a value is the same as multiplying by the reciprocal. If you really want to write it as 4.29 over 4.29, feel free. So our new standard deviation is 1. And that's a big idea throughout the course. If you standardize the distribution, the mean is 0 and the standard deviation is 1. The shape, whether you subtract 67, divide by 4.29, it doesn't matter. The shape remains unchanged. It remains the same. In fact, I made a graph here in Fathom. It's a stats software where I took each height, and you'll notice, you'll recognize this distribution from above. It's centered at 0, shape's the same, as long as I type in all the numbers right. Standard deviation is now 1, centers at 0, shape's the same. So, in conclusion, transforming data, what does it do to measures of shape, center, and spread? And for your benefit, there's a question for you to ponder, just like the dinosaur there. I'll see you in class.